GCSE revision video for Unit 1, question 6 from the higher paper, or question 15 from the intermediate paper. So let's have a quick look at the question. It's a factorising question, and so the thinking that we're going to use for this is one of 4 steps. We are going to look at all the factors in each part of the expression. We're then going to look at which of those factors are common, so are shared by both parts of the expression. And we're going to use some brackets to take out, if you like, the highest common factor. And then we'll do a little check at the end just to make sure we've got it right by expanding those brackets. So let's have a look at some alternative questions before we tackle that actual exam question. So the first one I'm going to look at is factorising 12x minus 20. And we're going to go right back to the beginning of how we factorise something. And I'm actually going to look at the prime factors of 12 and of 20. Just to inform our planning. So you should be familiar with the factor trees. And when I do that for 12 and 20, I can see that we've got 2 2's, i.e. 4, because 2 times 2 is 4, which is a common factor in both 12 and 20. That means that if I was to write this green expression out for both terms, I can have a 4 in there. So I've got 4 in both terms. So that means that 4 times 3 is the same as 12, and I've got the x, and 4 times 5 is the same as 20. So my little factor tree just helps me figure out which is the factors I need to think about. My next step is to think about which are common. So I've got a 4 in both of those terms, and nothing else is common. So now I can put the 4 on the outside of my bracket and think about what needs to go inside my bracket. So I've got 3x in the first term, and I've got a 5 in the second term, or the last term, but I've also got a negative sign in the middle. So in my bracket I'll have 3x minus the 5. So make sure you get that sign right. And I'll grade this out so we know not to leave this as our final answer, but I'm just going to check it by expanding. So I do my a little claw or branches, or however you like to think of it, and I expand my brackets out. So remember, this is not your answer that you put for the exam, okay, but you do it somewhere at the side of your paper just to check. My final answer is 4 bracket 3x minus 5, and then close your bracket. Okay, let's have a look at this second one then. Again, very quickly, I'm just going to look at my factor trees. You may be able to do this kind of factorising or spot the common factor without doing that, but again I can see I've got 2 2's in both of these factor trees, which means I know 4 is a common factor. So I'm just going to write that out. 4 times 2 is the same as 8, and xy I've written as x times y, just to be really clear. And 20 is the same as 4 times the 5, and I've got it's 20y, so I've got times by y there. If I look at what's common in both of those, I've got 4 is common in both those bits, and the y is as well. So at the front of my brackets, I've got 4y. What else do I need inside the brackets? I need 2x for the first term and plus 5 from the second term. Quick check by expanding, and you've got it right. And the last one then. So again, a bit easier now because 7 is a prime number, so I don't need to factorise that, or I can't factorise it any further other than 7 and 1. So the only prime factor of 7 is 7, and 21 is 7 times 3. So I can see pretty quick that 7 is my only common factor in the numbers. And I'm going to write it out so I can examine the algebraic bits in there. So I've got 7 is common in both. And because we've got x squared y, I've written x times y. Because we had y cubed, I've written y times y times y. And again, you might be able to spot this without doing that. That's absolutely fine. But I know that I've got a y that is common to both. So in front of my brackets, I've got 7y. And that leaves me with here 3x times x, or x squared, minus y times y, which is y squared. So I can put those 2 terms in my bracket. Quick expansion again at the end, and hopefully everything's okay. So now let's look at our exam question. I'm going to think about my factors. So again, I've got the number 12, and I can split that into, or write down into its prime factors 2, 2, and 3 is obviously already prime. So the common factor there is 3 in both of those. So when I expand this out a little bit, explode these terms if you like, I've got 3 times 4 times x plus 3 times x times y. What's common in both of those? Well, the 3 is, and I've got an x is common in both of those, so I know that 3x is going in front of my bracket. That's the highest common factor that I can take out. It's common to both, and it's the highest it could be. So that means I need a 4x at the first term and plus y to complete it. So that's it done for the 2 marks, and I've made that very clear in the working out space. But I would also do a little check somewhere on the page to give me the confidence that I've got that right. Let's have a look at 3 more examples just to fine tune that skill. So 36ab squared, just the b being squared, plus 14ab. So you might be very happy to kind of look at the factors of 36 and 14 without drawing the trees, but we can identify that 2 is a common factor to both, and that means that 36 is the same as 2 times 18 and 14 is the same as 2 times 7. So if I write that out with the algebraic bits as well, I've got 2 times 18 times a times b plus 2 times 7 times a times b. So I can see my common factors are 2, and also I've got a times b is common in both as well. So my highest common factor there is 2ab, so I can pull that to the front of my bracket, and that means I've got 18b plus 7 inside the bracket. On the next one, 5 and 15, pretty easy to spot. Hopefully that 5 is your factor, common factor, and so 5 times e cubed minus 5 times 3 times e squared. So I can see that 5 that we talked about is a common factor, and this time I've got e times e, or e squared, is also common as well. So I've got 5e squared at the front, e take away 3 in the bracket. In this last one, 14 and 35, should know that they're both multiples of 7, 2 lots of 7 and 5 lots of 7, so 7 is my factor of the numbers, and then d times e squared and d times e for the second one. So my common factors then, I've got 7, I've got d, and I've also got e, so I can put that all together, 7de, which means in the bracket I need 2e minus 5. Okay, so bonus material on this little video is I'm just going to look at these 6 factorising questions and see if we can spot some differences in what they look like and how we can kind of figure out the answers. This first question, very similar to what we've just been doing. I've got some r's and t's in both expressions. I've got r times t squared and r cubed times t, and I can see there's a common factor of 3 in both of these numbers. And so I know 3rt will be my common factor, and I'll be left with 5t plus 2r squared in the bracket. So that one should be fairly familiar. On this next one, if I look at both kind of terms in this expression, there is no common factor, but what I do notice, and this should be a bell ringing in your head, is 49 as a square number. So that can be written as t squared minus 7 squared, and this is a really beautiful expansion of t minus 7, t plus 7, or you could put the plus first and the minus second. And this one is known as the difference of 2 squares. And if you expand this bracket using your claw or your foil technique, you'll see that the minus 7t and the plus 7t cancel out, and you're always left with this very nice t squared minus 49. So difference of 2 squares is a fairly straightforward factorisation, as long as you spot you've got the square number. Let's have a look at the next one down, 3t squared minus 147. And again, you might be thinking, well, is it a difference of 2 squares because there's no t's here, and I can't see instantly any common factor. Maybe this 3 is a common factor. Does 3 go into 147? Well, I know 3 goes into 150, and that's 3 less than 150, so yes it does. So I can think of this as 3t squared minus 3 lots of 49. And so if I've got 3 lots of t squared minus 49, t squared minus 49, I know is t plus 7, t minus 7. So again, the difference is 2 squares here, but with an additional 3 put in there to make it a bit trickier. In the last column, we've all three of these are quadratics, where we've got a squared variable. So we've got a squared t, we've got a number of t's in the middle, and we've got a constant on the end. So all of these factorise in one way or another into a double bracket. Because we just have a t squared at the front, we've got a t at the front of both of these brackets. And then I need to consider the numbers at the end of these brackets in each one, and they need to multiply in this case to give me 49. Now 49 we've met before. We know 7 times 7 gives me 49. I can't think of any other factors apart from 1 and 49. And I also need to get minus 14t. So if I had minus 7 and minus 7, and I expanded that, either just go to one side and do it, or do it in my head, I know that's going to give me minus 7t and another minus 7t, minus 14t. And in this case, because both brackets are the same, I could write it as t minus 7 squared, and that is what we call a perfect square. The next one, similar approach to start with. We're going to have t and t at the front of the brackets, and I need to get negative 21. And so factors of 21 are 7 and 3, or 1 and 21. And once I think of those factors, I think about negative 4, and I can get negative 4 if I use 7 and 3 with the subtraction and the adding in the right place. So if I have minus 7 plus 3, I know that will give me minus 4t. The last one, because we have a 2t squared, one of the brackets needs to start with a 2t and the other one just with a lonely t on its own. And again, I need to make 21 on the end, so it's going to have to be 7 and 3, or 1 and 21. And you probably need to practice a little bit so you spot what numbers are going to be best, and you can try it a few ways around. But if I combine 3 and the 7 times by the 2, I can't quite get 1t out, or negative 1t out. If I did it the other way around, I could have 7t, and here I would have 6t, and there I might be able to make my minus t in the middle. I might be able to make that 1t. And so if I went for this option, 2t minus 7 and t plus 3, and I expanded it out, I would get the right answer. The best thing to do with these is either have a little look and research the AC method of factorising, but because this one starts with a prime number here, 2t squared, it's pretty quick to just have a little explore of the few options, have a couple of trials and see where you get to, and if it's not right, swap the numbers around in the end, maybe swap the signs around, see if you can get there in the end. Okay, but just be aware, lots of different types of factorising. Look out for difference of two squares, look out for perfect squares, and practice your FOIL or your expanding to check, see if you've got it right. So I hope that helps on factorising. A couple more videos on difference of two squares and things like that, so have a look around and good luck.